Hello and welcome. This is our group presentation for Mathematics 142. Our research assignment is based on the use of rockets using mathematical principles to launch a rocket into space, which uses many forms of calculus and algebraic manipulation. This is used by mechanical engineers and aeronautical engineers to launch satellites for use for major communication works and exploration throughout space. Please enjoy our presentation.
To derive Tsiolkovsky's equation, first we start with conservation of momentum and start with the fact that as the exhaust mass decreases, so does rocket mass. So the momentum of the rocket is equal to the momentum of the exhaust. So that's a change in mass of the exhaust times net exhaust velocity. That's this. Then if we expand, if we just substitute momentum into this equation here, so mass times velocity, and then over here we just sub this into this equation, we can then expand this equation out into here, cancel the two terms on the sides and cancel the t's. We end up with a variable separable differential equation, which we can rearrange and integrate. When we integrate, we get a log using the limits initial mass and final mass. We'll eventually get this equation here, which is Tsiolkovsky's equation. Alright, so engineers use this formula when they're building their rockets because they will know the mass of their rocket when it's full and when it's empty. And also they know the velocity of the exhaust, which is based on the engine that's used. If they know that, they know how much the rocket can accelerate. That's it.
Right. Kepler's law is the period squared over distance cubed relative to 4 pi squared on the gravitational constant of the big M, the planet, and the satellite. Kepler's law allows us to figure out the altitude which Kepler's law allows us to relate period to the altitude, and from that we can figure out the velocity that the satellite needs to remain in that orbit.
One of the main satellites used are geostations, which are used for GPS and major communications. The geostation has the same period as the Earth, so therefore that the period is 24 hours. A satellite dish on Earth can always be pointed at the satellite and always knowing where it is relative to the Earth. GPS uses a number of geostations to triangulate a location, which is often up to 12 satellites. Using Kepler's law to find the radius with the period as 24 hours is then able to determine the velocity of the satellite required. Using this, then it is determined the fuel and the desired mass of the rocket to get into orbit.